Hey everybody, here is the resistivity problem, the somewhat more challenging one, all right? So check this one out. It's about as hard as a resistivity problem can get, but we'll go over all the basic stuff that we need to remember to how we do this stuff right. Okay, so what we have a 4.92 meter long wire, has a radius of 0.78 millimeters, and has a resistance of 0.144 ohms. You getting this? Does this ring any bells for you? All right, so we're asking then, what's the wire made from? Well, how would you determine what the wire is made from? Let's take a look at the formula, shall we? So the formula for this is that the resistance equals rho L over A. Well, if we look at what we're given, are we given resistance? Sure. Given length? We're not given area. We're given radius, but we could turn radius into area using pi r squared, correct? Yes, there's only one other trick here. Notice that the radius is not given in meters. Radius is given in millimeters. So we're going to have to convert that to meters. Let's convert that first so that we're going into the formula with the proper units. And the rest should fall out easily to give us rho. Well, rho is unique to each substance. So when we find rho, we will also be aware then of it's only one substance, at least on our reference tables, that would have that particular resistivity. So if we find the resistivity, we just identified the substance. So let's have at it, shall we? First, let's consider that, well, we'll get to area in a second, but first we have to take 0.78 millimeters, and we need to convert that into meters. Now, how do you do that? If you say, well, you just divide by 1,000, no, you don't do that. That's not correct physics. If you divide by 1,000, you just made it 1,000 times smaller. Granted, that's going to be what happens on your calculator, but please remember, the only number you can multiply this by is 1. So the question is then, what form of 1? This is how we don't mess things up right at the beginning. So what form of 1? Well, we want to convert millimeters, so they better be down here so they'll cancel out, and we want to convert them to meters. So what form of 1 will make meters and millimeters equal each other? Well, 1 meter is the same as 1,000 millimeters. So very easily, that works out. So we end up just dividing that 0.78 divided by 1,000. All right, and put it in scientific notation to make it nice and easy to use. And that's going to come out to 7.8 times 10 to the minus 4th meters. Very handy. And now let's draw that circle. It's really good to diagram stuff, so you keep it clear in your head. And the radius is your 7.8 times 10 to the minus 4th meters. Okay, just ringing some bells. What do we do with that? Well, pi r squared. Pi r squared. So take the radius that you have now, hit x squared, and then times pi. What do you get? Okay, so the area there is 1.91 times 10 to the minus 6th meters squared. That radius was squared, so of course the units are squared too. All right, so we have that. I think I'll just leave that right in the calculator. That way I have all the significant figures in it, and while we only have need of a few of them, it's best to round at the end of the problem. That also is good physics, and we're trying to learn good physics here. So we now have what we need to start the problem, all right? As always, givens, formula, S and S, good physics. So what are the givens? Well, the length equals 4.92 meters. The area equals 1.91 times 10 to the minus 6 meters squared. We have the resistance equals 0.144 ohms. We're looking for rho. Do we have everything we need? We sure do. The formula. Remember, good physics. Write down the formula as it comes right out of your formula table in the reference table. You know that one's correct. That's resistance equals rho L over A. Well, we're manipulating it to solve for rho, so how do we do that? Well, if we multiply both sides by A, cancel the A's there. If we divide both sides by L, cancel the L's there, we're left with rho. We're also left with a little bit of a mess. So when you go to your S&S, that substitution and solution stage, rewrite that so it's not a mess. Too often people can make a silly mistake because they left a mess and they just put the wrong thing in the wrong place. It's really easy to do. So when you're doing good physics, do it right. That's rho equals, we'll say RA over L. Okay, you're just about done now. Now you can substitute in. The resistance we'll say 0.144 ohms. Why don't we just write 0.144 ohms? Why do we always put the 0 there? Look at the size of the decimal point. It would be really easy to miss. If you put the 0 in front, you don't miss the decimal point. Again, good physics. Messing this up would make your answer way off. So you need to make sure you see these things. So 0.144. Also, it's not 0.144. It's 0.144. Make sure you're saying this stuff. Make sure you're doing it right. Remember, physics is worth it. So 0.144 ohms. Area is 1.91 times 10 to the minus 6th meters squared. The length is 4.92 meters. Before we go anywhere, check the units. Are the units going to work out here? We want rho. What units does rho have? Well, rho, if you look at the reference table, rho is ohm times meter. So do we have that? This meter cancels out that meter squared. I have ohm meters. Yes, we're doing it correctly. Okay, so let's go ahead and multiply this stuff in then. I have left the 1.91 in my calculator, so that has all the useful significant figures and then some, times 0.144 divided by 4.92. Okay then. I'll give you a second. Did you get the answer? Take a second. If you did it right, your answer should come out something close to 5.59 times 10 to the minus 8th ohm meters. That is my answer. All right? So, what do I do with that? Well, if I look at the reference tables, I can see, comparing all the different resistivities I have here, I have one that says 5.60. Well, 5.59 and 5.660 is pretty darn close. Times 10 to the minus 8th ohm meters. And that substance is tungsten. So this wire must be made of tungsten. Now, why would anybody be using a tungsten wire? This is not my problem. Normally, you would not use tungsten for many wiring applications at all. It's extremely expensive, but it does have an extraordinarily high melting point and is useful for a variety of different applications. In any case, that's the answer. That must be the wire. So that's how you do a resistivity problem. I hope this helps, and I'll see you on the next one. Hey, thanks for watching.